What's up, guys? It's Dr. Yerby here again, and this is Learning Module 2. In this one we're going to be talking about the Windows file system and other types of file systems and Windows in general. So let's jump right in. Alright, so first is why Windows? Why do we care so much about Windows? Well, we can see looking at the market share that Windows really still owns the market. Yes, this graphic here is as of July 2017, and we can see even though Windows 7 is scheduled to go off of support, I think Windows 2020 is the final twilight date where they'll quit offering updates. We can see that almost 50% of the market is still using Windows 7. I'm using Windows 7 right now to record this video. But then even if we jump down to the next one, Windows 10, and then Windows 8, and 6% Windows XP, and then we finally start getting to that little operating system known as OS X, right? And then we have a few Linux and we have a few other. So Windows is so important and so talked about because it's been around for a while, it's mature, most of the tools are written to work using Windows and to work to investigate Windows as far as our cyber forensic tools. So that's why we spend so much time on Windows, and we still talk about the Mac forensics, and we'll have a separate learning module, I think learning module 12 in this course, where we dedicate it just to those other alternative operating systems. So some important things that you need to know relating to cyber forensics is the anatomy of a hard drive. So most of your forensic investigations aren't going to actually require you to open a hard drive, to rip open an actual hard drive. If the drive isn't spinning and it's not something that you can replace on the outside of the outside of the drive, typically if it's not a matter of national security, that drive is just probably not going to end up being included into your evidence, right? So I think that's one of those myths that people who aren't in the field, don't work on it. They think that everyone has an electron microscope and you can go down there and start breaking apart the platters and look on there. So that really is not very typical. But it's still smart to know the anatomy of the devices that you're working on, so that if there is something that you can replace, that you know what it is. And there's a website that you'll go to in one of these learning modules where I have a simulator that will show you the different sounds and the way that different things work when maybe an actuator arm is broken. So maybe you can replace that actuator arm and then you'll be able to acquire that device. Okay. The other part inside that hard drive is the actual set of disk. So you have tracks, which would be kind of like a slice of pizza. The sectors would be the part of that track. So yeah, and then the platters are each of the disc. So I have an old stack of, these are just CDs, but imagine these are my platters. And then it's also important, what you will be reporting at times if you're doing manual file carving, or if you're reporting the findings of where a file is located, especially if it's a file that was hidden in Slack or some unpartitioned space, you might be needing to report this is where that file was, or these are the different locations starting at this sector, this track, and this is where the file was. You can calculate the total size of a drive using this formula here at the bottom. So it's the number of cylinders times the number of heads times the number of sectors times the number of bytes per sector. Okay. Alright, next we'll talk about the file system. So again, we'll spend a little more time on Windows, but really I'm just going to go through and list these, and then you can use your textbook and the internet to find out more about the different attributes and limitations of each type of file system. So Windows file systems, we have all of these different ones: FAT, FAT16, FAT12, didn't really see that one very often, 32, FATX, that's the one that's used in the Xbox, right? NTFS, which is the new technology file system. So this is the one that most of the Windows computers out there are running. and it's just funny that the N stands for new, although this was released in 1993. So some of you watching this video probably weren't even born at that point. They have changed versions a few times up to version 3.1 now, and again you can go out there and look at the different specs about the different attributes of each file system. It's really some security, the length that the attributes can be, different things that you can change. And then the new one that's recently released, first on server 2012, is the REFS, the Resilient File System. And so this one is being kind of, when Windows 8 came out, it used NTFS, and they've since made it where through some updates, Windows 8.1, when that big update, that big patch came out to move you from Windows 8 to 8.1, they made it where you can switch your file system over to REFS, and then Windows 10 can also take advantage of REFS. And so one of the neat things about REFS is the size that a file system can be. It can go up to 1 yobibyte. So a yottabyte is 10 to the 24th power, or that huge number here at the bottom of your screen. And a yobibyte is much larger, so it's I think it's 10 to the 80th power. Right, and just for some quick comparison of what a yottabyte versus a yobibyte looks like, I have this graphic for you. Alright? Alright. These jokes are to entertain me, not you. But that's a Voodoo Donut in Portland. Delicious. Other file systems you might see for Mac, some of the file systems I use is HFS, the Hierarchical File System, and HFS Plus. When you're searching through that, you primarily use something called Finder. Linux has ext2, 3, and 4, so each of those are just extensions on the other one. 4 is the newer one, and it includes some journaling, keeping up with files a little bit better. These aren't as popular, but you can still see them out there. There's, probably several hundred distributions of Linux, if not more. So you can see RiserFS, XFS, JFS, and then some of these other platforms out there, BSD, Solaris, Unix, they can use that. AS400 uses its own, right? So there's plenty of them out there, but the main ones that you'll want to be concerned with doing most of your investigations will be first Windows, then Mac, then Linux, and then everything else kind of falls into that other category. Sometimes when you're doing a forensic investigation, you may have to go seek out a specialist in that, very niche market. All right, and one last slide here. So some other really important things to consider when you're doing a forensics investigation using Windows is to look in the registry. There's tons of information in the registry, when things were changed, when there's passwords, and you will see a much different registry when you acquire this using a forensic tool versus trying to go in there signed in with the computer powered on, signed into the operating system. So it's really important to look at that registry using a forensically sound tool. Right? The event viewer can show you all sorts of different events. And there are some anti-forensics that we'll talk about at some point in the semester where you can go in there and really mess with the event viewer and make it look like some events happened at a different time, or you can delete event viewer. So it's not infallible, but it's still a really good resource in your forensics investigation. Browsers, browser history, metadata, and that one's not unique to those. Like I said, the last two aren't really unique to Windows operating system, but the data about the data can be very useful. Shadow copies, something I believe was enabled in Windows 7, and then BitLocker. So another interesting point that I made earlier is that we're not going to be taking apart a hard drive and examining it unless it's a matter of national security. Well, another sad realization is that when a lot of law enforcement officers encounter encryption, they'll give it a few tries using a few tools that they have out there, and depending on the caseload and the technology available and the skill and whatever, the sad truth is just that encryption is really a stop block, and Windows BitLocker is one of those encryptions that is not easily crackable. So we think about it as a privacy concern, or as a privacy matter, and we think, great. Think about that as a forensic investigator, we think, oh, that stinks, right? So we'll, again, later in the semester, we'll talk about some of those issues related with encryption, such as the San Bernardino Apple iPhone case. But that's all we'll do for this learning module. Thank you, Dr. Yerby, and this has been Learning Module 2. Thanks.